Now we turn to a little problem which I like because I worked with that in my research days, is how does a mathematician draw a snowflake? You have a beautiful drawing here of a snowflake. It's rare to find a snowflake which is that perfect, but it happens. Okay, how does a mathematician draw a snowflake? If you have a piece of paper, you can try and draw it. You start with a triangle, same side, you know, for everywhere, and I chose a 9 centimeter triangle because 9 is nice, you can divide it by 3 and again by 3. Okay, so you draw this triangle. Then you take this triangle again and you will complicate each side of the triangle. You are going to cut into 3 parts. So each part is 3 centimeters. And the middle part you erase and you replace it by 2 wiggles, which are also 3 centimeters. So this size is a little bit more complicated. You do the same thing for the other 2 sides of the triangle, and you get a beautiful star. Now, here again, you have straight lines. They are 3 centimeters each. You will apply the same thing, that is, you will cut it into 3, and you will get 1 centimeters each. And the center part you replace with a wiggle, like 1 centimeter, and that's what you get. That's already a more complicated figure. And you can continue like that. Well, on a piece of paper, it's hard. You can do one more step. A computer can do it even better. And why do mathematicians want to study this kind of shape? They are very interesting because they represent the irregularities that you meet in nature. When you want to study the coastline, for example, of a country, it's not a straight line. So people wonder, how are we going to measure it? Well, it depends on the length of your measuring stick. If I want to measure the length of this table, for example, well, I will take a stick which has a certain dimension and I will displace it 1, 2, 3, 4, and I will say, okay, the length is 4 times the length of that. If I cut this in half, I'll have to displace this twice as many times. That's normal for a straight line, and I will measure a length which does not depend on the length of my measuring stick. Let's do that for this fractal object. Okay, can you measure the outline of this mathematical snowflake? Well, if I take a 9 centimeter stick, how many times will I have to displace it to make the whole contour? Once, 2, 3, and so I will say approximately with a 9 centimeter stick the length is 3 times 9, that's 27. But you know very well that I left out a lot of details. I neglected that. If I want to take those details into account, what should I do? Take a smaller stick. So if you do that, you take a 3 centimeter stick. What will happen? I start with you 1, 2, 3, 4, and I have only covered 1/3 of the whole contour. So the whole contour will be 4 times 3, that's 12, times 3 centimeter, I'm already up to 36 centimeters. And if I cut the length a little more, that is, if I want to measure the coastline and I take into account more details, more little coves, more little rocks, with a smaller stick, eventually the length, the smaller the stick, the longer the length. And that's where mathematics and physics differ. The mathematician will tell you, okay, if the length of the stick goes to 0, the length of the contour will go to infinity. Well, we all know that we cannot have a stick which is too small. It cannot be smaller than 1 atom, for example. So there is a physical limit that they mathematically gladly ignore. So they will say that it goes to infinity. So that's one kind of example of mathematical object which has been invented by the mathematician to be able to study real objects which are not simple straight lines, and to teach how to measure